Okay, we are learning the last section in our derivatives unit. We are learning the derivatives of the trig functions. There are 6 trig functions, so that means 6 new formulas that you will be learning. I'm going to start with sine of x, and I'm going to show you that the derivative of sine of x, what that is, but I'm going to do it based on a graph. We haven't talked a lot about the derivative graphically, so listen up and I'll show you how that's going to work out. So I'm going to start over here on the left with a graph of the sine of x. So let's start with graphing sine. So here's pi, 2 pi. Okay, and so sine is 0 at the pi's, which that's not 0, is it? That would be 0. And, well, then 1 and -1 at the half marks. This is a little messy. Okay, so here's my graph of sine. Okay, based on this graph, I'm going to try to figure out what the graph of the derivative f prime of x would be, and I'm going to graph that on the right. First of all, I'm going to point out that derivative is slope. Derivative is slope. And so you look at this cyclic function, which is sine, and you think about the slope. So at the high points and the low points, which I'm color coding in green here, what would be the slope of the curve at these highs and lows? Well, think about tangent lines. When you envision a tangent line here, you can see that as you went up the hill and then at the crest where this point is, it's a flat tangent line, and then you go back down the hill. So at all of these green locations, I have flat horizontal tangent lines. And a horizontal tangent line would have a slope of 0, which would mean that my derivative is 0 there. And so I get a derivative of 0 at the halves of pi, at the odd powers, at the odd pi half marks. And that should trigger your memory. Who is 0 at the halves? It's a little clue as to what the derivative will be. And so we're 0 at the half marks. And then I'm just going to point out one more thing, and that is that in sine of x between negative pi halves and pi halves, my sine graph goes up. I am increasing. And so when you increase, when your curve is increasing, that would mean that your slope is positive because all tangent lines are sloped upwards. And so that means we have a positive derivative. The final thing I want to point out here is that I'm steepest. Think about where this hill is steepest. It is the steepest right here, smack dab in the middle at 0. And so that means that if my curve is the steepest at 0, that would mean that the derivative is the maximum at 0. And so I'm going to put a maximum derivative at 0, and I'm going to have all positive values. Positive values are just things, are y values that live above the x-axis. And if you guessed, this will turn out to be this graph. The derivative will turn out to be this graph. And who is that the graph of? It's the graph of cosine of x. And so the derivative of sine of x is cosine of x. All right, one down. Now we're going to find the derivative of cosine of x. And I am going to use the definition of the derivative to do this. It's been a long time, but I don't know if you'll remember this, but the derivative of f, this is good exam review, is the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. And so if my function, let's call this f of x, is cosine of x, then my derivative is the limit as delta x goes to 0 of the cosine of x plus delta x minus the cosine of x over delta x. Okay, now you don't have to be able to do this, but you do need to write this down and listen to me. I'm going to eventually come up with the derivative of cosine of x. I have to use a trig identity here. The cosine of x plus delta x, that is the cosine of x times the cosine of delta x. Okay, so I've expanded my cosine of x plus delta x using this trig identity, and that was cosine of x, cosine of delta x minus sine of x, sine of delta x, and then I recopied the rest of my limit, and I have also gone through and distributed my delta x down here. I've distributed it first over here to the cosine of x plus delta x, and I brought this minus cosine of x over here. And then the sine of x delta x, which was left, I put on the right side. Okay, now the reason why I've done this, and I'm not going to explain it any further because this is just a derivation, is that right here, this limit turns out to be 0. And this limit is minus sine of x times, as delta x goes to 0, this value goes to 1. And so your answer is negative sine of x. So you just need to know the punchline here. What is the derivative of cosine of x? It is negative sine of x. Okay. Now on the next page, so that's 2 out of the 6. And on the next page, on this page right here, we're going to write down all 6. I'm going to write them down in a very systematic, formulaic way, and then I'm going to show you why I wrote it down that way. Okay, actually, we're going to get to that in just a second. Sorry. First of all, we're going to find the derivative of tangent of x. We are going to do this together, and I do think that you should be able to do this, especially if you can't remember a formula. You can always derive them. It's very easy to do. You simply take tangent of x and you replace it with sine of x divided by cosine of x. And now I can take the derivative of this because I can do the quotient rule. And so we're going to label f as sine of x and g as cosine of x. So f prime is cosine and g prime is negative sine. These are the two derivatives I just gave you the formulas for. And now I can use the quotient rule. So my derivative is f prime g minus fg prime over g squared. And so now I just fill in there f prime g cosine of x times cosine of x minus fg prime. That would be 2 sine of x's, one of whom was negative, so that would make that sine squared plus cosine squared over g squared. G was my cosine of x. Now, what's sine squared plus cosine squared? That's that trig identity that you really, really use all the time. That one is 1. And so we have 1 over cosine squared of x. That is secant squared of x. And so you have just figured out that the derivative of tangent of x is secant squared of x. All right, so 3 down. Before I tell you the other 3, I do want us to do some practice problems. Okay, so for number 1 here, I have sort of a polynomial, only I have this minus sine of x in. So when I take the derivative of the 3 is 0, plus, now I'm using the power rule, the derivative of 2x squared is 4x, minus, what is the derivative of sine of x? It is cosine of x. And that's your answer. So that's number 1. Most people don't write the 0. Then we're going to go on to number 2. Now we're going to go on to number 2. Here I have a quotient, and so I need to use the quotient rule. So my top is f, that will be 3x, and my bottom is g, that's cosine of x. So f prime is 3, g prime is negative sine of x. And so I'm going to use my quotient rule, f prime g minus fg prime over g squared. So this is going to be 3 cosine of x minus 3x negative sine of x, that's why I made that a plus, all divided by cosine squared. And I'm just going to leave it here like that, no simplifying. And the last little simple example problem I want to do is I want to find the equation of a line. This time I'm going to find the equation of something called the normal line. The normal line is like the tangent line, but it's not. It is the line perpendicular to the tangent line. All right, so when lines are perpendicular, then their slopes are opposite reciprocals. Slopes are opposite reciprocals. And so, to find the equation of the normal line, I need to find the slope of the normal line. But that will just be the opposite reciprocal of the slope of the tangent line. And we have done a lot of problems in which we find the slope of the tangent line. To do the slope of the tangent line, we find the derivative. So I'm going to find the derivative of y. That would be 3x squared times the cosine of x plus x cubed times the negative sine of x. Notice here I used the product rule. Okay, let's not do this at x equals 0, or at x equals 2. Let's do this at x equals 0. Okay, so then my tangent line has slope, oh no, then I'm going to have a slope of 0. I can't do that. Okay, we're going to do it at x equals pi. So we're going to have some weird pi's in our answer, but that's okay. So my slope of my tangent line is my derivative with pi plugged in. So that'd be 3 pi squared times the cosine of pi plus minus pi cubed times the sine of pi. All right, and the cosine of pi is negative 1, and the sine of pi is 0. And so my slope of my tangent line is negative 3 pi squared. Therefore, my slope of my normal line, which is the line I'm looking for, that'll just be 1 over 3 pi squared, since it's the opposite reciprocal. And now I just need to use my point, which I don't think I have the whole point. I only have x. If I plug in pi to y, I get pi cubed times the cosine of pi, and the cosine of pi is negative 1, because it's negative pi to the third. So now to find the equation of my line, I have the point pi, negative pi to the third, and I have the slope 1 over 3 pi squared, and I'm just going to plug into my point slope formula. So y plus pi to the third equals 1 over 3 pi squared x minus pi. We'll just leave it like that. Okay, now we're going to write down all 6 the derivative of all 6 trig functions. Okay, these are the 3 you already know. The derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of tangent is secant squared. There are 3 more. These are the other 3. So starting here with y equals cotangent of x. If y is the cotangent of x, then the derivative of cotangent is negative cosecant squared x. And another one we haven't learned yet, y equals secant of x. If y equals secant of x, then y prime is secant x times tangent x. And finally, if y equals cosecant of x, then y prime is negative cosecant x times cotangent of x. So we have 6 formulas that you have to learn. 1, 2, 3, 4, 5, 6. Yes, you have to memorize all 6 of these right now. Do it as best as you can. You have to know them all for your quiz and for your test and for your final and for your exam. Okay, so I want to point out some easy things that you can do to try to memorize them, because there are a lot of patterns that happen. First of all, sine and cosine, they're each other's derivatives, except cosine's derivative, the derivative of cosine is negative sine. And then I want to point out some partnerships that we have going on. Secant and tangent are involved with each other, right? The derivative of tangent is secant squared. Derivative of secant is secant tangent. Same thing with cotangent and cosecant. And the last thing that I want to point out is that when a trig function starts with C, the letter C, cosine, cotangent, and cosecant, that's when its derivative is negative. See that? Cosine, cotangent, and cosecant all are the only ones who have derivatives that are negative. And so all of those tricks will help you, but doing problems is going to help as well. And so let's do some problems. We have 4 examples on this page, and then I think I might have one more example on the next page, and then we'll be done. Yes. Okay, so I'm going to start with this first one here. Y equals x squared times the cosecant of x. Notice this is a product, and so I will use the product rule. I'm going to label f as x squared and g as cosecant x, and then I'm going to take f prime and g prime, and I know the derivative of cosecant is negative cosecant times cotangent. And so my derivative is just the product rule. So f prime g plus f g prime. All right, that was a negative, so I'm just going to change my positive to negative. Okay? And now on this next one, I'm going to leave that there. That's fine. The next one, I don't have a product. I have an e, an exponential. And so I have to use the derivative of the exponential rule, which is that the derivative is the same thing. So the derivative of e to the sine of x is e to the sine of x. But I'm going to use the chain rule because you always have to use the chain rule. And I'm going to multiply by the derivative of the exponent of the exponential, which is the inside. And the derivative of the inside here is the derivative of sine. And what's the derivative of sine? It is cosine. And so that's your answer for B. Okay, now let's do C. In C, we have a quotient. So I'm going to use the quotient rule. F will be tangent of x. G will be 1 minus tangent of x. So the derivative of tangent is secant squared. And here my g prime is going to be 0 minus the derivative of tangent, so negative secant squared. And now I'm going to use the quotient rule, f prime g minus fg prime, but I'm going to minus a negative here, so that's just tangent secant squared, all divided by the denominator squared. I am going to simplify the top here only because it simplifies so beautifully. Let's go ahead and distribute the secant squared to this parenthesis. Do you see it? The tangent x and secant squared x in the numerator are the same and opposite signs, and so they cancel. Here they are. Negative secant squared tangent x, positive secant squared tangent x, same thing. They cancel. And so I'm just left with secant squared over 1 minus tangent of x, quantity squared. And now I'm going to leave the last one for you. I will tell you it is not a product, right? This is not a product. This requires the chain rule, not the product rule. Remember, a product is something with x times something with x. This is the cotangent of e to the x, and so you have that inside-outside. So leave this one's for homework. Well, yeah. Okay, last question. We're going to show that the graph of y equals cosecant of x has a horizontal tangent line, at x equals pi halves. So remember, tangent lines are, or the derivative is the slope of the tangent line. So I'm going to start with the derivative of cosecant of x. That is negative cosecant x times cotangent of x. And now the slope of my tangent line would be the derivative. And they're telling me they want me to do it at x equals pi halves. So I'm going to plug in pi halves here. and I get the negative cosecant of pi halves times the cotangent of pi halves. And now you need to remember your trig. This is 1 over the sine of pi halves, and the sine of pi halves is 1. And the cotangent of pi halves would be the cosine of pi halves divided by the sine of pi halves. The cosine of pi halves is 0. And so negative 1 times 0 is 0. So the slope of my tangent line is 0. We have a horizontal tangent line. All right, that is it for this lesson.